right, thanks everybody. If you guys don't mind, I'm just a little bit behind schedule due to we're waiting on the drone here for about 15 minutes. Actually, I'm not going to blame it on the drone. I had technical difficulties, so I pushed it back a little bit. Real quick, I put an agenda together, and I want to talk about mobile scanning a little bit. So I want to make sure if anybody came here just to see that it was available, and if you guys had any questions, to let Eric go ahead and come up here and speak about that real quick, and see if you guys make sure you get everything answered for him. Also, again, you'll be able to see this when you walk outside to take a look at the drone, and if you want to see the 3D RV. While we're waiting for Eric, I know what it's like to sit there. That's a reason we didn't offer lunch today. You didn't get pizza because I know that's the worst. The eyes get real heavy, right? Makes it a little bit difficult. So to give him a second here to get set up, make sure this is correct. We've got a couple giveaways. Make sure everybody's still awake and paying attention to raise their hand if they're awake. The first one, this is a Starbucks gift card, so I wanted to see who drove the farthest, and I want to give them a cup of coffee for their drive home. So anybody over 2 hours? Yeah, if you work for Autodesk and you had to be here, you don't know.
If you're driving an RSV.
Yeah. Where's TJ at? There we go. All right, anybody over 3 hours?
Yeah.
All right. Chris, let me get this for you real quick. Everyone can pass it back. I'm blinded. Cool. All right, the next one, anybody? Did that come up?
No, not yet.
Let's see real quick here if I got 3 of them open. Here we go. Not sure. All right, so one more real quick. Anybody going to buy a scanner in the next 6 months? You guys are learning real quick. All right, we'll do a quick presentation. We'll give a couple more of these away.
Thanks, Chad. So we changed the agenda a little bit. My presentation here is going to be very, very basic, very short. The goal was to talk briefly about mobile mapping. And then Chad was going to do some InfraWorks demos and bring some some freeway data from a mobile LiDAR project into InfraWorks and show 6-7 miles, I think it was.
Yeah, it's going to. Yep, we'll see
that. So he broke the golden rule of live demos at a presentation. So I try to never do that. So mobile LiDAR, we're just going to talk basics. How many in here have either are familiar with the technology or have even contracted services and use this technology on projects? So we've got people in here that are familiar. This is our truck, road vehicle. Our system that we'll talk about is very portable, very rigid. Does not rely on vehicle power, so it can transfer between vehicle platforms very easily. ATVs, boats. You saw Chad's slides earlier. But basic sensor configuration for all systems. You've got an IMU. You've got some form of CPU, whether it's on board or a laptop that you're operating within the vehicle. You've got your LiDAR sensor, GPS. Some systems run dual GPS. In a marine environment or a rail environment, we'd run dual GPS so that we can align heading with the IMU. And then cameras. Our particular system has 6 cameras for full 360-degree coverage. Other systems, maybe only have 2 cameras, 4. There's variations in system or sensor configuration. But in general, mobile LiDAR systems consist of the LiDAR sensor, the GPS, the IMU, the PC to store and record and synchronize all data, and then the cameras, of course. So that's the full system. And we've got our system here. When we go outside, I think we're going to go outside and do a drone flight. The truck and the system is sitting next to the RV, so everyone can Nathan's out there now. Nathan's our primary guy that's doing most of the data processing. So any technical questions, feel free to talk to Nate about. Pick his brain. You probably won't be able to stump him, but the system's out there, so go check it out. So we talk about accuracy to sort of piggyback off the last presentation here. It's important to, we can talk about accuracy, but then we need to talk about, is it global or relative? So for this particular system, it's true survey grade mobile mapping. So true survey grade mobile LiDAR at 1.1 million points per second. And in Open Sky GPS, these are the IMU specs. The IMU is the backbone of the system. You want to buy the best IMU you can afford. Pay more for the IMU. It's the most important component of the entire system.
What is the IMU?
The IMU is an inertial measurement unit, or INS, maybe some people have heard of it. So it measures vehicle position change 200 times a second. So your GPS position is measuring at 1 epoch. So you get GPS position 1 time a second. Your IMU is measuring vehicle or position change, sensor change in all 3 axes 200 times a second. So ultimately what you get is a 3D trajectory with a XYZ or WGS84 lat long ellipsoid height position 200 times every second along your vehicle travel path. So spend the money on the IMU. The IMU is the most important system, sensor of the system. That's how we can get, the IMU is how we can get 2 centimeter global accuracy in Open Sky GPS. The IMU and the GPS work together. But it's important to understand the difference between global and relative. You'll have mobile sensors out there and they'll say we're 5 millimeters. Our system's accurate to 5 millimeters. That's a relative accuracy statement. That's point to point in the LiDAR data. That's no different than setting up your static scanner, doing a single scan, and then measuring in that scan a point to a point. Very, very accurate. It's as accurate as the LiDAR sensor. When we talk global, you've got to consider all sources of error. So you've got survey control, you've got GNSS, you've got IMU. You've got to bring all these errors. And how well can we reproduce that position on say, a control point? We scan today, we scan next week, we scan in 6 months. Can we repeat that position? That's global accuracy, and it's important to know the difference. When we're doing highway DOT level surveying, very accurate design level from a mobile standpoint, not plant accurate, but for civil application accurate, we're talking about sub 600ths of a foot, so sub 2 centimeter. And this would be like a sample accuracy report. We put down ground control targets, similar to helicopter LiDAR or aerial photogrammetry, where we paint targets, precisely survey those targets, GPS XY, multiple observations, average solutions, and then digital level. And then we withhold every 2/3 of those targets we'll withhold from the constraint. So if you can see here, the ATs and the VTs. The ATs are what we use to acquire the data. So we constrain the trajectory to those ATs. And then the validation targets, or the VTs, are targets that we withhold from the adjustment. They're independent validations. So we constrain the data, and then we compare all of our independent validation targets to the LiDAR data set. And you can see just some of the results that we get on a typical engineering grade survey for a freeway, like the screenshot that you saw there in the very beginning. We're very easily achieving sub 2 centimeter. Generally, you're in the 2 to 300ths range once you've controlled the data. Unadjusted, you're sitting around 2 to 3 centimeters. So prior to applying ground control adjustments, 2 to 3 centimeters. So it's very important to understand the differences between global and relative accuracies. And then, just sort of wrapping up here. Again, wanting to keep this basic, not knowing how many people have been involved in mobile mapping, so I want to keep it more basic and then just open it to questions. But multi-platforms. Chad showed, I think, these same images earlier, but we've collected data on ATVs. I mean, you could put it on a golf cart, you could put it on a push cart if it's outdoor work. A boat, we've done river corridors for bank stabilization projects. I mean, we just recently did a project. It was 22 miles of river corridor. We put it on that boat and collected data downstream and upstream, both passes, and produced a unified data set. And the data was collected in 5 hours. And then just some snapshots of some of the types of, it's just LiDAR data. Once we've got the final produced data sets, it's LiDAR data. Now, in the civil applications, mobile environment, we're generally dealing with LAS files, but certainly we can export PTS or E57 even. All formats certainly are supported. And then at this point, we're in the feature extract mode. So we're producing 3D engineering grade, CAD models, extracting those edges of pavement, striping, back of curb, gutter lines, drainage features, manholes, things like that, producing your standard CAD deliverables. Just some variations in colorization. Everyone's seen point clouds. Everyone here knows what point clouds are, so this is nothing new, of course. just some different projects, some different types of projects that we've completed. And really all I'm showing here are just, of course, the LiDAR data, but we're capturing the imagery. And the imagery becomes very important when we start doing feature extraction for civil projects. So we're marching down this freeway corridor and creating our planimetric, 3D planimetric CAD deliverables. The images are very important because we use those images for identifying features. We don't want technicians having to spin LiDAR clouds around. We don't have plant level density from a static scan. We're a profiler scanner traveling down the freeway at 50 miles an hour, so our data is not that dense. It's very, very dense for a mobile type civil project, but for folks that are used to plant or static level scanning, it's not that dense. So the images are very important, help identify features. We can see power poles in the imagery, and it really speeds up the feature extraction production levels for the technicians for producing those CAD drawings. And that was really about it. I mean, the intent here was to be very brief, open it up to questions, and then turn it over to Chad to show some data that he's pulled into some of the Autodesk products.
Cool. Any questions? He's going to be around. Also, you mentioned Nate's around here as well, so they'll be out by the truck when we walk out there. If you guys see Nate, he said, could you stump him? Just ask him how many photos he took during what was the boat project.
Yeah. Yeah, I mean, we're
a great way to
hundreds and hundreds of thousands of images on a project. So.
Yeah. Cool. Thanks, Eric. Anything else? He'll be around for a little while as well. Answer some more questions. All right. So I think I got the data yesterday, the day before at least. It's been a while. A lot of things to do when you're having a presentation. You got to worry about your own files. I think he gave me, was it 50 gigs of data, Eric, something like that? Right. What was it, maybe 56, maybe a little bit more than that? Literally, so there's just a list of LiDAR scans that go all the way down, on this, the jump drive that he handed me, the USB drive. So I started importing it in. I kind of forgot about it. I was like, I need to do that. I got to show that data. So I started doing it. It took, I don't know, maybe 20 minutes or a half hour. This is only 50% of the data, and I had to come back over and help out over here. But you can see this is miles and miles of road data clearly being shown in the recap. So if you want to take this into Civil 3D, or my goal in the future, you'll see a presentation using InfraWorks, and we will tie this in and actually put this right in the location that it was. Right, you see it's pretty good. So literally you can start extracting this information and using this data live in whatever Autodesk program that you want to share that. Oh, oozing out? That's a lot of data, isn't it? 55 mile an hour, capturing 70 mile an hour, whatever the highway speed is, being able to capture that information, which is very, very cool.